at any time. Um, so yeah, as I mentioned, this is one of our sort of fundamental programming topics. So, throughout the semester, we've kind of been alternating between drawing stuff and learning about graphics and shapes and things like that, and then more fundamental programming topics. So the ones that we've covered so far are really just variables. That's one of our fundamental programming topics. Um, and then conditional logic is the second one. So this is the really like the third main topic that we're covering as far as like basic programming rules. Um, Functions, what we're going to do next week is kind of the next main topic we'll cover. And that's pretty much it for this semester. There's a couple other things that if you continue taking programming classes, you'll learn like objects and arrays and things like that that we might touch on a little bit as we get later into the semester. But those are kind of the four main topics that any programmer should get out of an intro level class. So just keep that in mind. It's just kind of for some awareness about how these things kind of fit into a more general programming education versus what we're doing, which is a combination of programming and multimedia. So yeah, let's talk about loops, and we'll do some examples first, and then we'll go over to P5. So I'm going to open the console just to do a few examples over here, just to kind of make things a little bit simpler. But I'll get open a P5 project so I can use this in a bit. So let's make a new project here and call this loops. Okay, so there's a lot of similarities between loops and a couple other of things that we've done a lot in this class so far. One is the draw function. The draw function is sometimes referred to when people are talking about P5 as the draw loop. And that's because the draw function gets called over and over and over again. And so we kind of saw a version of this with the example that we were actually just looking at when we were talking about some of the assignments, the state example. So let's go back there for a second. So in this example, we have like a state number, and then we kind of move one by one through that state as we're clicking the mouse. So each time I click, I get a different piece of text, and then we continue. Um, this is sort of like a loop, right? Because we loop back to the beginning. So we start with click me, we go through a few lines, and then we come back to the beginning with click me. And that's kind of, a loop is something that repeats itself. So that's kind of a version of a loop, but it's taking place in a few different parts. Like the state logic is here in the mouse pressed function, and the drawing stuff is down here in the draw function. So in the loops that we're going to make today, everything's going to be wrapped up into this one thing. And it's also going to take place instantly, not over a series of frames. So the draw loop happens, as we make changes, we see those changes because the draw loop is kind of refreshing. And if something changes, we see the changes over time. But if we want to do a bunch of things at once in one frame of drawing, that's when we use a loop. So we're repeating, but we're repeating all in one frame. So if we want to draw, 10 fish or something like that, that's a good reason to use a loop. The other thing that loops are similar to is our conditional statements. And so this is kind of what a conditional statement looks like. We learned about this a couple weeks ago. So we always have a keyword if, and then we always have some condition. So something like 0 equals 0. And then we have a curly bracket block with some code where, if the condition is true, we're going to say alert true or whatever our code is. And if the condition is false, then, this won't happen. So if we say if 0 does not equal 0, then that alert never occurs. So the other term for this that we used in the last class was control flow. So we're using different things that we know about the data of our program to control what happens in the program. And so control flow involves different types of things like loops and conditions and functions. And so just like a condition with a loop, we have a lot of the same stuff. We still have like a keyword like the if here, And we still have some conditions. With a loop, we have more than one condition. So that's the big difference, is that we need multiple conditions to track to make our loop work correctly. And then we also have our same curly brackets for the code that we want to run in the conditional if the condition is true, in the loop, however many times our condition stays true. So a loop is just like a conditional, except we want it to happen more than once. So we change the condition after each time we run the code. That's the big difference. So we can look at a while loop. A while loop looks almost exactly like a for loop, except you're changing if for while. We usually don't use while loops in this class, or I barely use them in my own code in practice because they're a little bit more dangerous because the parameters are not all in the same place, and we'll see what that looks like when we do a for loop in a minute. But a while loop is just a good way to show that you have an if statement here and a while statement here. They look almost exactly the same. The difference is just this term, and it changes how it behaves. So let's look at this first example first. So I'm going to create a variable called I and start it at 0. And you're going to see I a lot as we start to talk about loops. I is used as programmers as a shorthand for index. There's other reasons, like historically, why it's used, but it's easy to just think about it meaning index. And an index is like where we are in a count. So if the index is 0, we're at the beginning. If the index is 1, 2, 3, we're going to count up through our counts. So that's why we use I for this. You don't have to, but that's a convention that you'll see a lot. So let's start with I at 0, and we say if I is less than 5. So we know that I is less than 5 because it's 0. We're going to say I plus plus. And just so we can see what I looks like, let's console.log I. And then let's close our condition. So what's going to happen if we run this code is it's going to say, is I less than 5? Well, I is 0, so yes, it is less than 5. Then we're going to add 1 to I here. That I plus plus gets added to I, and then I goes from 0 to 1, and then we're going to log I. So we'll see the result 1. Okay, so that happens once because we use if. Now, if we want to do that a few times, if we want to count multiple states, then we would just run that code again. So we'd say if I is less than 5, there we see now I is 2. We can run the whole thing again. So in the console, if I just hit the up key, it's going to go to the last statement that I executed, which is the same if statement. So I'm just doing this so I don't have to type the whole thing again. It's sort of like if I, copied and then just pasted this right in here. So then if I run this again, now I is 3. Okay, so I'll run it again. I is 4. And now, so 4 is still less than 5. So now I is 5. If we run our code again, notice that it didn't print out I. And if we look at what is the value of I, it's stuck at 5. So no matter how many more times I run that code, it's not ever going to count again because this condition is now false. So with a while statement, we can do all of that without having to copy and paste that code to repeat that code. A while statement will do it for us. So I can say while, well, let's set I back to 0. So I'll say variable I equals 0. Oops, oh, I've already declared I. So let's refresh the page and try it again. So let's say I equals 0. And now instead of if, I'm going to say while I is less than 5. We're going to do the same exact code, I plus plus console.log I. And now I'm going to hit this once, and notice it goes 1, 2, 3, 4, 5. So this is a loop. It repeats the code inside of the brackets for as long as this condition is true. So when I is 0, it's less than 5. And so we run the code and then we go back to the beginning. And so now I is 1, it's still less than 5. And so we do I plus plus, that gives us the 2 down here. And then we go back to the beginning. And with a while loop or any other type of loop, we continue going back around to the top and running that block of code again as long as our condition is true. And as soon as this condition becomes false, so as soon as I equals 5, 5 is no longer less than 5, so it stops running. So that's a while loop. And what we'll see with our next loop, our for loop, which is the much more common loop that you'll see in use in JavaScript and in production code in general, our for loop looks almost exactly the same, except notice that the conditions are all in one place. So I have variable I equals 0. Here I have let I equals 0. I'll explain let in just a second. Then I have I is less than 5. Here I have I is less than 5 as my second condition. Whoops. Here I have I plus plus, and here I have I plus plus as the final condition. So what a for loop does is it groups the three parts of a loop that we need, where we start, how long we go for, and what changes each time. And it groups them into one place, so that way we're much less error prone, and we can read all of our conditions in one place, as opposed to the while loop where we have one condition up here, we have another condition here, and then we have what changes inside the code block itself. So different people have different preferences. They technically work the same way, but the for loop is what you'll see a lot more often. So I'll talk about let real quick and then go over this example. So usually when we declare a variable, we say something like variable I equals 0. Sometimes when we create a variable, we say something like let I equals 0. There's well, I get an error there because of how let works, but you just ignore that. The difference between var and let is not much. The only real difference is that let is only going to exist inside of its current area, whereas var will exist everywhere in our program. So for example, this let I is only going to exist inside the for loop, versus if I had variable here, it would keep existing after the for loop, which is not what I want. So you can see up here, I use variable I because I want I to exist inside here as well as in the main program. Down here, I only want I to exist inside my for loop, so I can use it again later if I have other loops that I want to run. So we can see that difference here. If I say for let I equals 0, I is less than 5, I plus plus, and then we'll console.log I. When I run that code, so I is created here. We know it exists inside the for loop, but if I go here and, oh, I probably need to refresh this because I've created I before. So let's try that again. So if I do my for loop, I is now undefined. So I get an error when I try to run I down here. So even though I created I up here, this I doesn't exist anymore. If I change that, if all I change in this code is from let to var, now when I run this, I actually exists, and it is equal to whatever the last condition for my for loop is. So that's the real difference here. It doesn't really matter that much which one you use, but let is probably a better condition to use here. So let's construct our for loop again. So we start with variable I equals 0, or let I equals 0. So I equals 0, again, is where we're going to start counting. And you don't have to start at 0. You could start at 1. You could start at 100. It doesn't really matter. It just depends on what you want to do with the code. And then our next condition, I is less than 5, this is our conditional. So whenever this is false, that's when our loop starts, or sorry, stops. And so that's a little counterintuitive because, we want to count until I is less than 5 or while I is less than 5. So it's a little counterintuitive, but we have to think about sort of the reverse condition is like, when is it going to no longer be true? And then the I++ at the end, like probably, half the time you see a loop, you're just going to see this I++, and that just means add 1 to I. So we're going to keep adding 1 to I over here until we hit this 5. And plus plus, again, is just a shorthand for +1. You don't have to use plus plus. We'll look at some examples in a second that don't use plus plus. But again, we can just console.log I and see that value go from 0, 1, 2, 3, 4. So anytime you want to do something a bunch of times, like let's say we wanted to draw a circle. I can't actually draw a circle here, but let's just say draw a circle. Whoops. So notice I drew 5 circles. Let's put an I in there so that we can actually see them on separate lines. Okay, so if we wanted to drive 5 circles, instead of writing circle 5 times, we can use a for loop to draw the same circle 5 times. Um, so, we don't have to use it just for counting. We can use it for just doing something multiple times, anytime we want to repeat something. So let's look at a couple more examples. So we don't have to, let's keep going. Okay, so we don't have to always count the same thing. So most of the time we're going to start at 0. That's what you'll see in most examples. But we could start at 1. There's no reason we can't start at 1. So let's say let I equals 1. I is less than 5. I plus plus. What we'll notice here is that our function, loop works basically the same, but we don't get to 5. So we increased where we start to 1. So we have 1, 2, 3, 4, but we still don't get to 5 because as soon as I becomes 5, our loop is going to stop because I is not less than 5. So we can either change 5 if we want to get to 5, or we can change this condition. So if we have I equals 1, I could change I to 6. And now we'll count 1, 2, 3, 4, 5. So a lot of time we count at 0 because then it's easier to do that math. 0 and then less than 6 is, or less than 5 is what's going to count 5 times versus 1, then we have to add 5 to 1 to get this ending condition that we want. The other way we could do it is just change this from less than to less than or equal to. So this will include 5 in the values that are acceptable for this condition. So we can also change this operator right here from less than to less than or equal to, and now we get 1, 2, 3, 4, 5. So we can also change how far we count and how much we count by. So let's do another example for let I equals 0, I is less than 100, I plus plus. And we'll console.log I. And hopefully you've already guessed what this will do. So it counts all the way from 0 up to 99. So again, we don't get to 100 because remember our condition, I is less than 100. So once we get to 99, our condition is not true anymore once we get to 100. So this is going to count from 0 to 99. If we want to include 100, we can switch this operator to a less than or equal to, and now we'll be able to count to 100. So we can also count in, not by ones, but by higher numbers. So if we wanted to count to 100 in tens, we can say I plus equals 5 instead of plus plus for 1. Let me fit that. I guess I could expand it this way. So now notice that we're counting by fives, 0, 5, 10, 15, 20. And so we could just go up by fives. We could count by tens, 0, 10, 20, 30, 40, 50. And so instead of just saying plus plus, we say plus equals, and then the value that we want to count by. So we can also count backwards. So we can start with a larger number for let I equals 10, and then we can say as long as I is greater than 0, so we're reversing the condition. So we're saying as long as I is greater than 0, now we can say I minus minus. And so we can count backwards rather than forwards. So we start at 10, and as long as 10 is greater than 0, we're going to take off 1 with I minus minus. So we go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So our loop is pretty, there's a lot of different variations we can do. There's a lot of flexibility in terms of how we use the loop. And, there's multiple ways to do different things. So let's look at some drawing with loops in P5. And I think with the visuals, we'll be able to see a little bit more about what's going on. So we'll move on to drawing with loops. And so what we're going to do here, I'm just going to walk us through these steps of turning 5 circles hard-coded into one loop. So let's start with 5 circles. Okay, so if we want to draw 5 circles on our canvas, start with a circle, and maybe I'll draw it at 0x, and let's put it in the middle. I'll put it at 200y, and let's make the circle 100 pixels wide. Okay, so we have one circle. So the easy way to make 5 more of these is just to copy and paste 5 more circles. So I know I'm drawing 5 circles, but they're all in the same place, so it only looks like one circle on the screen. So if I want to see the circles, then I have to increase the value of where they're being drawn. So let's move our first circle to 100. Then we can move our second circle to 200. And move our fourth circle to 300. And move our fifth circle to 400. Okay, so you might have already started to figure out what we can do to change our circles here. So let's actually move these circles up a little bit. Let's put these at 0. And we'll draw 5 more circles, but this time we'll do it using a loop. And so let me do this. Let's leave these guys here, but I'm going to copy and paste. And then I'll set these to 0. So we can have these here as a reference. So this is 5 circles hard coded. Okay, so now we have some circles down here. I don't know why it's not trying. Huh, this is weird. How come I don't see these circles? Oh, I put the size as 0, not the y value. Whoops. Okay, let's set the size back to 100. And let's set the y to 0. Okay. So now we have some circles, and so we can think about what's changing in between these circles. So we have a 0, 100, 200, 300, 400. This one is, just 200, 200, 200, 200, so this one doesn't change. And then the size also doesn't change, 100, 100, 100, 100. So if we want to draw these circles, what we need to do is figure out how are they the same and how are they different, and how can we, count in between. So let's imagine instead of 0, we have, let's do variable x equals 0. And so now I can put x here. And so now I can think about this value. So what is this value relative to 0? Well, we just added 100. So this is just x plus 100. Okay. And the next one is x plus 200. So the difference between 100 and 200 is just 100. So we could redo this by saying x plus equals 100. So instead of adding 100 to x here, we could just add x plus equals 100 each time we draw a new circle. That will move us across the screen exactly the same way. So now notice that my circle functions are exactly the same. So that's good because if I want to put something in a loop, I can't change the code. I have to change the values inside the code. Okay, so now we have circle X and we have all of our circles look exactly the same. So now we can start to think about how to create a loop, and we already have some conditions, right? We have x equals 0. We have x plus equals 100, which looks a lot like our third condition that we need in a loop. The only thing we need to know is when do we stop? And so we know that after we get to 400, we don't want to keep going anymore. And so we can use that as our ending condition. So let's go ahead and turn this into a loop. So let's put 4 at the beginning and put in a parentheses to start our loop. And now we just need the ending condition. So we can say x is less than or equal to 400. And now I can grab this changing condition and finish up my loop. I don't need the semicolon at the end. That's like a little bit of a weird quirk of how we write loops, is that we have like one statement with a semicolon, second statement with a semicolon, last statement, we do not need a semicolon here. So then I can add in my bracket, and now this loop is doing all of this work for me. So what I used to have to do in several lines of code, this part of the code is doing it, multiple times. So I can remove this bit and it still looks the same. There I have my loop. So now I can draw a circle 5 times without having to without having to repeat it, uh, by figuring out where does it start, how long does it go, and what are the differences in between. And so let's try a couple things. We'll notice what changes when we change these different numbers. Um, yeah. hmm that's a good question. I don't actually know. Let's see what happens. If I put the semicolon back in here, yeah, it gives me an error. So, so it'll give me an error and it says unexpected token semicolon. So yeah, we have to take this out. I don't really know why it does that, but that's just how it works. Yeah. Okay, so let's play around with these numbers a little bit and see what happens. So the first one is where we start. So we're starting at 0, which is the left side of the canvas. If I start somewhere else, like 200, it's not gonna draw 5 circles anymore. So we're not actually counting 1, 2, 3, 4, 5. We're more dividing space across the canvas. So we'll do another example where we count. But in this case, we're just using the conditions that we have for drawing to recreate our circles. So if I change X, it changes where I start. And I could go negative if I go like negative 200. There are probably some circles that are being drawn over here, but they're not on the canvas, so we don't see them. So there's no real reason to do that. If we change our ending condition, this changes where we end over here. So if I change it to 200, now we just get the first 3 circles. If I go to 100, just get the first 2. If I go to like 1, we're just going to get 1 circle. So this changes the left and the right sides, but not how many times we actually count. With this condition, this is how much space or how much we move x by. And so if we change this value, we're also going to be changing the number of circles because we're always going to keep going until x gets to the end of the canvas. So if I change this to like 5, we get tons of circles. If I change it to 25, we get a lot of circles. If I change it to something bigger than 100, like 200, now we just get a few circles because we're making bigger jumps in between. And if I change it to something that's not quite on, like 150, now we still get 3 circles, but they're not evenly distributed because this 150 is not like half of 400 or quarter of 400 or something like that. But it still pays attention to where it starts and stops. So that's one way to draw a loop, is by using the x value and just counting and figuring out the space. But if we want to draw a specific number of circles, regardless of the size of the canvas or the size of the circles themselves, we can still use a counter. So for that, we need to add some other variables to keep track of. So there's a little bit more code. I'm going to change this x to a let so I don't rewrite it later. So let's say we just want 5 circles. So I'll have a variable and I'll call this number of circles, and I'll set this to 5. So I only want 5 circles regardless of how much space they take up. So now instead of using x, I'm going to use I. So I'm counting instead of using space. So I'll say for let I equals 0. Then I'll say I is less than num circles. So we can change the number of circles if we want. And then I'll say I plus plus. So we're just counting up by 1. Now if I put in the same code, circle x at, let's move it down a little bit. So let's say 400 and 100 for the size. So I get an error, right? Because there is no x. I'm using I instead of x to calculate where I am. to count. So I need to calculate x based on I, right? I is still counting up, so I can still figure out how far I'm supposed to go. So let's make a new variable, and I want to keep it inside this for loop, so I'm going to use let. I'm going to say let x equal, and then I'm just going to multiply I times the value that I want for x. So I'll start with 100. This is what's going to be the same as the previous one, but we can see other versions of this. So if I say I times 100, let's change the fill down here so we can see the difference here. This is green is our second. So we'll start with fill is blue. And then for our first for loop, we'll say fill is red. Okay, so now we can see our green circles are in the same place, but we're just counting to 5. So if we change the number of circles, if I change it to 10, we still see 5 circles here, but I can change how much this 100 is. So if I change this to 50, now we have 10 circles. And if I change the size to 50, we'll see those 10 circles. So if we're counting, in this case, we don't see them because they are still going off the screen. But if we're counting, we can update what we want x to be to get that value. So let's go back to 5 for a second. So why does this work? If I is 0, I times 100 is going to be 0, right? 0 times any number is 0. So our first x is the same as let x equal 0. Our first x is 0 on the left side of the canvas over here. So then I becomes 1. So in the first example, we added 100 to x. In the second example, when I equals 1, 1 times 100 is 100. So it's basically the same thing as adding 100 each time, but using a different type of math. And so this way we have a number of circles, and then we have the amount of space that we want. And we can also use more math to say how big those circles should be. So I can say, what is the width of a circle? So I can say circle width, and it can be the size of the canvas, so 400, divided by the number of circles that I want to draw. So now instead of I times 100, I can say I times circle width, and that will be the same. Um, uh, let's see. I don't know why it changed that way though. 1, 2, 3, 4, 5. Let's see if I do I is less than or equal to. Okay, but that's not right. Huh, this math is off. Let's see what this math says. So let's console.log circle width. I'm probably just missing something. So it's 80. We have 5 circles. Oh, but we're filling more than just the width of the canvas because we're overlapping a little bit. Forgot about that. Okay. So we really are doing like 500 because we have extra. Okay. So yeah, now we're filling our circles. So it's really the width of the canvas plus 100, but let's just fill the canvas itself. So let's say 400 times the number of circles, and let's just move it over. So what we can do, instead of I times circle width, we'll say uh, circle width plus I times circle width, and actually we need to divide this by 2. Sorry, this got a lot more complicated quickly, but let's talk about what's happening. There we go. Okay, so now what we're doing, it's a little bit more complicated, but essentially what we're doing is we're saying, so I starts at 0, so here's 0, times um, uh, plus the circle width over 2. Oops, okay. I equals 0 plus the circle width over 2. So that's the starting point. So 0 plus half the circle width. We know that the circle is drawn from the middle, so we need to actually move over a little bit to get the math to work out right. So we're going to move here, but then we're going to say what's I times circle width? It's 0 here, so we add nothing here. Then when I is 1, this is one circle width. So from the middle of one circle to the middle of the next circle. So then 2 widths of the circle. So we are basically adding half plus 1 width, 2 widths, 3 widths, 4 widths. And so that's how we can fit our circles into the space correctly. So half the circle width plus I, where we are in our count, times the circle width. And now if I change the number of circles to 10, all of our circles fit inside. If I change it to 3, they'll fit inside. If I change it to 400, they're probably too small. Let's try 200. Still too small. Let's try 100. Okay, now you can kind of see them. They're pretty small. So let's do 50. There you go. You can kind of see them now. Anyway, we can make as many circles as we want and fit them into the space. So there's a few different ways to do this. There's not one way that's necessarily right, but depending on what you want to do, there's different things that are kind of useful. Um, okay, so we're just going to go over a couple more things, and then I'll let you guys do some work in class. So now that we can kind of like do multiple copies of something, we may want to kind of create some patterns based on it. So I'm going to go back up here into this section and just make like a really simple self-portrait just to show that right now I'm just drawing one circle, which isn't very exciting. I can draw more than one circle. So let's draw some self-portraits. So uh, let's, we have circle is, x 200 by 100. So we could also draw another circle in here. I'm going to turn off, I'm going to say no stroke. And let's change the fill to pink. And let's draw another circle. This time I'm going to take X, and this is going to look a little bit familiar from our interactive self-portrait code. I'm going to take X, and for the first eye of my self-portrait, I'm going to subtract like 20, and then I'm going to take the 200 and subtract like 20, and then I'll draw a smaller circle. And I have to do fill red here. So then I have an eye, and then I'll put another eye to the left. Okay, so now I can do a whole composition inside of my loop. And just like my interactive self-portrait, as long as I'm using this X as a reference, then it will update. So this eye over here, let's say this is the left eye and right eye. So the circle moves by X, and each eye also moves by X. Okay, so we could also do a fill for the mouth. Let's just leave the fill here. So let's just do a rectangle. So we'll take X as it is in the middle. We'll add a bit to Y. So we'll say Y plus 20. And for a rectangle, let's say 40 for the width and 10 for the height and 5 for some rounded corners. Uh-oh. Oh, I don't have Y. I should use this 200. Although I'm using it so much at this point, I'm like, I should just have a variable. But let's just say 200 plus 20. Okay, so we got the rectangle. Oh, I'm not using rect mode center. So let's say rect mode center. So there we've got our little mouth. Um, so we can create compositions and repeat them. And so we can start to create patterns in our canvas. And we can also do some variations. So we'll do some more interesting variations on Wednesday, but for now I'm just going to change some things based on where we are with the X, just to kind of show this example. So we can show something changing over time. So I'm going to use a fill here, and instead of pink, I'm just going to put in X value. I'm going to use the changing X. So just like in our interaction examples, we don't want to throw X in there directly because it doesn't match the size of the canvas. So instead, what I'll do is I'll create a color. So I'll say C for color, and I'll map X from 0 to 400. So same thing as our interaction, except now our loop is moving for us instead of our mouse. And so we'll map 0 to 255, And I'll just put the C in for now, just so we can see that changing. So now you can see over here, our self-portrait has a black eye and mouth, and then gray, lighter gray, and finally white. So we can actually create variations across our loop the same way that we would when we're mapping our mouse value for mouse X or mouse Y in our canvas. So I'm not going to do too much more with that because we can create some more interesting variations using random. But that's one way that you can create variation if you want kind of like a gradient going across. So if we made this bigger, so let's say I made my canvas like 800. For now, we'd have to update some stuff. So let's see, what do we need to update? Well, first of all, this 400 will match the width. So instead of using a hard-coded value there, let's just put in for it the width value. So that's gonna mean that it stops at the end of the canvas regardless of how big it is. Notice my circles up here don't change, and I'd have to just keep copying and pasting those circles, so I don't really want to do that. Um, but then our width needs to change down here as well. So we're mapping from 0 to the width, and so we get this nice gradient. We could also use that as a red value, so I could say 0, 0, and then we'd see it changing from black to red. So you can use it just the way you would use it in any other instance. Um, and then for our circles at the bottom, uh, we would change this 400 because we're dividing the width of the canvas by the number of circles we want. So we'd put width in there. And so now our green circles match our red circles. So that's a couple different examples of how to use the loop in your drawing code. There's a lot of different ways you could do it, but this is kind of a good starting point. So for our first assignment with loops, you can think about a pattern that you want to repeat, and then you can think about variations to that pattern to make the repetition more interesting. So there's a lot of different things that do this in the real world. Like if you're designing a t-shirt or a poster or something like that. There's a lot of things that use repetitive patterns. So it's a good thing to be able to do to prototype or to come up with different design ideas. So for our assignment, we'll just start with a basic loop, and you can add some variation. And then on Wednesday, we'll look at adding randomness to make more interesting variation. So I'll stop there, and I'll stop the recording and see if there are any questions.